My name is Dorin. I work for a company called SportRadar. I'm a tech lead. Probably haven't heard of the company. I'm not here promoting it. I do open source, and so far my most notable contribution has been a MIG driver that I wrote, which I will talk more about later. So today we're going to talk about functional testing. And to give you some background, my history with functional tests starts in 2013 when I was put in charge of a project which aimed at rewriting a large legacy code base. And one of the things that I knew from day one was that I wanted high test coverage for this. And that's because for many years before this project, I worked with that legacy code base. And I witnessed firsthand the code rot that ensues when developers are reluctant to refactor. And that wasn't because of laziness, it was because of lack of tests. So everybody was doing their best to try to alter as little code as possible, and the code received frequent revisions. But you didn't want to have any side effects, and you had no way of knowing for sure that you weren't going to have any. So naturally, you avoided touching code that you didn't necessarily have to do. And it wasn't long until we figured out that this is the recommended approach to doing it. And what this pyramid represents is the three types of tests that you should be using to cover. And the height of this pyramid is the runtime of the test, because unit tests are fastest, and acceptance tests are slower, and end-to-end tests are the slowest. Which is why we're using a pyramid for this, because you're encouraged to have as many of these as possible, and fewer acceptance tests, and even fewer end-to-end tests. And the focus is going to be the tip of that pyramid. We're not going to get into acceptance tests or unit tests. And even when you do apply this principle, you minimize the number of end-to-end tests you try to have as few as possible, and you make up for it in coverage with the acceptance tests and unit tests. You will still end up with a very large test suite, which only increases with every feature that you add, right? And these tests are inherently slow, and that's because of all the services they hit. Typical scenario is your test runner running in PHP has to communicate with Selenium, which controls our browser, telling it to make a request against the web server, which spawns another PHP process, which will most likely communicate with the database. And all of these are blocking I/O, right? All these arrows here. And one way to tackle this, one way to optimize it, is to use an emulator, where your most critical scenarios, you split your test suite into two types, and your most critical scenarios will run with the slowest workflow through the browser, while the bulk of your tests actually use a faster emulator. And there are multiple types of emulators. They vary a lot, but the typical one, let's say, is a headless browser, which skips the rendering part, but does all the other work, and thus doesn't require a window manager. So it has less overhead than an actual browser. Some emulators take this further, like Goot, for example. Some emulators take this further by skipping Selenium and or by actually emulating the DOM and not supporting JavaScript or CSS. Right? And Goot does this, skipping JavaScript and CSS, which limits its use cases quite a lot, because then naturally any page that you have that requires JavaScript to work you won't be able to test with a driver like this. So you can only really test some basics, and you can sometimes get passing tests even though the feature doesn't work as intended. And when, for example, the DOM node is visible and Good can see it, it's emulating the DOM, but it doesn't know that JavaScript was actually removing the node or hiding it. Symfony takes this a step further and skips the web browser as well in the Symfony kernel driver for Mink. So instead of dispatching a request to the web server, which will then spawn a PHP process running Symfony, what it'll do is instantiate the Symfony kernel and give it a request and say, here's a request, handle it, right? But the request was never sent to a web server and it was never received. So naturally, it's going to be faster. But even with that, we still have, so now the bulk of our tests are faster, right? They're still not terribly fast, and their number is still increasing, both the ones that run in a browser and the ones that run in an emulator. So as the project progresses and we get more and more features, our test suite increases, and so do our build times, right? So with build times increasing, our queues are now stacking up, waiting longer, and developers are slacking, legitimately. So an obvious solution to this, the most obvious one, is to use some concurrency. But it's not really as simple as this, right? Because in this case, for example, we solved the problem of the queue growing larger and larger, but we're still not making individual builds faster, right? So developer has to wait longer to get feedback on, did I break something? And we're also not really utilizing these new nodes that well. For example, in this case, right? This is just a lower load time. It happened that only 3 features were pushed, and these runners are just lacking, right? And we can tackle that by splitting the test suite into a number of chunks. Let's say 4, for example, in this case, where 4 runners each execute 25% of the test suite, right? So now, in times of lower load, one branch could, in a branch, the tests could potentially run up to 4 times faster. And I'm saying the tests could run up to 4 times faster, not the build could run 4 times faster, because tests aren't everything that run in our build, right? There are things that make no sense to split up, such as dependencies, because all the chunks are still going to need the same packages. We're not going to split those 4 ways. And ideally, we're also not going to install 4 times on each runner. So what we need for this is a building stage, which only runs once for each branch, for each push, and runs all the commands that are necessary to give us a working copy of the code, right? And depending on your project, this is probably going to include Composer install, Yarn or NPM, Webpack aesthetic, and warming up the cache, right? This is a typical use case. And after this is done, we take all the directories that were created by this process, such as vendor or node modules, and we compress it into what's called a build artifact, which will then be uploaded somewhere, right? So after this point, each runner can download this artifact, and they can now concurrently run the portion of the test suite that's assigned to them. But concurrency requires isolation, right? These are tests that hit the database, and we don't want 2 of them hitting the same database. They'll be overriding their data and affecting each other's outcomes. For example, this kind of workflow won't do. right? We're using the same database here. So what we have to aim for is full isolation. So we could technically reuse a Selenium hub and a web server. I won't get into that, and we'll stick with full isolation. And this is where, in my case at least, GitLab CI and Docker came in handy. Together they help simplify the setup that it takes to achieve this concurrency and isolation. Because Docker can spawn the same container multiple times. It can keep things isolated. It can give us our services that we need, MySQL, maybe we need Elasticsearch, and we need one for each instance. Right, and I won't be able to get too much into GitLab CI and Docker. I don't want to derail here. But what I can show you is example configuration for how to do the workflow that I showed earlier. So we have a building stage, right? And the way we can achieve this in GitLab CI is we create a build that's called build. That's part of the build stage. It's just a coincidence. A stage can have multiple jobs. It just so happened that this one only needs one, and the same name is suitable for both. And we define a Docker image that will run this. Right? GitLab CI will then spawn an instance of this and run this code, right? And in this case, I simplified it by just putting rake, right? In your case, you probably have Composer install and then yarn and whatever else you have. And then we need to tell GitLab CI the files, the paths to the files that we need to include in our artifact, right? So Composer and assets and cache in this case. And GitLab CI will then take care of spawning the Docker image, running the script, compressing and uploading the artifact. We don't need to worry about that at all. The only thing that we need to keep in mind here is the name of the job build, because we'll need this later. And this is what the testing stage will look like, except we'll have 4 of these rather than just 1. And they each have to have a unique job name, which I'm just defining the chunk 1 for now. So now the stage is test, but we run the same Docker image. We just need PHP 7.1. And the script is whatever way you have of running a specific subset of the test suite. Like in this case, it's a suite that has that's named chunk 1. And we see 2 new settings here. Dependencies tells GitLab CI that we need the artifact that was uploaded by the job named build before we can proceed. And services says, I need a unique instance of a container based on this Docker image, MySQL 5.6. And you can have as many of these as possible. You can download dependencies for multiple builds if you want to build your front-end assets separately or anything like that. So now GitLab will automatically take care of this, downloading the artifact from build on each runner and then running this command in an instance of this Docker image. And this is what it looks like in GitLab. We have the building stage. This needs to run first, and this blocks the other ones. As soon as this succeeds, then we proceed to download and run them, right? Unless this fails, in which case these are skipped, but we can retry each job individually as long as the dependencies have passed. But concurrency won't get you that far if your code is badly optimized. And unfortunately, I can't tell you how to optimize your own code because that's very specific to your project. But one thing that I can show you is this one profiling that you'll eventually end up with if you're running end-to-end tests in a browser. This is a real profiling in XHprof or of our Behat test suite when we were still running Selenium on Chrome. And this is after we optimized everything that was in our control to optimize, right? So you can see that what we ended up with is just one function, curl exec, taking roughly 10 times as much as the second most used one, right? And we ignored this one at first because this curl exec, this is the communication with Selenium. So when PHP needs to do an action, it sends a request to Selenium, it tells it to do this. And Selenium controls the browser into doing that. And for example, in the case of a request, only when the browser is done rendering that request will this curl exec return, right? So all that time goes into here, and at first it seems like, okay, there's nothing we can do about this, right? And when you're done with some of the other stuff, you'll eventually figure, okay, maybe there is something we can do about this. Maybe we can optimize the MySQL config running in CI so those requests are faster in CI and thus shaving some time off of this, right? But the actual overhead comes with the workflow that's followed for this. Because PHP needs to make an HTTP request to Selenium. Selenium makes another HTTP request to the WebDriver extension, which then uses extension API to control the browser. So this considerable overhead here, consider a click, for example. We need to find the element, that's one action, 2 HTTP requests. Then we need to move our cursor over it, that's 2 more HTTP requests. Then we need to send a click event, right? So we have 6 HTTP requests for something as basic as clicking an element, right? And an ideal scenario would be one in which we don't make HTTP requests at all, and we cut out both the middlemen. We communicate over a sock so that we no longer have to incur the overhead of transmitting and receiving headers, especially not 6 for a click, right? And it sounded like a crazy idea, a bit too ideal, but after doing some research, found that Chrome implements a protocol called DevTools, which allows you to control the browser over a WebSocket, right? And I used that to write a Mink driver, which excludes Selenium and WebDriver from this workflow when working with Chrome. It only supports Chrome, unfortunately, but it is fully compatible with the Selenium 2 driver, right? So replacing it should be as simple as installing the package and configuring a couple of things, right? And the result was that running a test suite of our BHAT suite has 1,800 scenarios, comprising 19,000 steps in total. And in Selenium running Chrome, this took 42 minutes in one single run, no concurrency, right? And after I switched to this workflow, the same suite ran in 14 minutes, right? But of course, in CI, the tests aren't everything we run, so the improvement wasn't as dramatic, but it was still great. That's because the build phase, installing dependencies, compiling assets, this stuff, takes about 4 minutes, and this can't proceed until that happens. But the runtime for this, the result of this in CI, I plotted here. These are all the successful builds 20 days before and after the transition. So what used to take between 17 and 40 minutes now takes between 6 and 16, or 7 and 17. And all the other conditions remain the same. It's the same test suite, running against the same browser. Nothing was actually changed. And there's a BHAT extension for using this driver with BHAT. So why did I choose Chrome? At first, it was because we were already running the suite against Chrome, and there was actually a considerable performance advantage when we switched from Firefox to Chrome, there was something like a 20% improvement, which was considerable. But I hear Firefox has caught up with the latest beta. I hear it's been actually beating Chrome in some benchmarks, so that's subject to change. But the main selling point of Chrome was this new feature they introduced in version 59, where you can run Chrome headless. And this is very powerful because it means that in that workflow I showed earlier, where you have a browser and an emulator, Chrome can actually take both roles. And this was actually so disrupting that the Phantom.js maintainer stepped down when it was announced. But because Chrome functions the same, more or less, whether it runs in browser mode or in headless mode, there's no longer a need to run it in browser mode in CI at all, right? We should be able to, any failure that happened in headless, we should be able, when debugging only, to reproduce it exactly as it happened, running in browser mode and seeing it for ourselves. So the workflow that we ended up with is simply, by default, locally as well as CI, just use Chrome headless, and only doing that, only running it in browser mode when we actually need to debug and see for ourselves. And the way we did that was by extending the Docker image that normally runs this, installing a window manager, a VNC server, so that we can connect to it and see the browser, and removing the headless flag, which is just one flag that it takes to run it like this. But two emulators still provide performance benefit that's sufficiently good that this workflow still makes sense. And that's kernel driver and Goot, which, while they have limited use cases, they are faster. They are considerably faster for those scenarios where you don't need them to run JavaScript, you don't need them to run CSS, you just need them to render the page, and then you make some assertions on the DOM, right, on what was generated in the page. So that's it for me. If you have any questions, I think we have a lot of time left. Yeah, go ahead.
So what about screenshots and recording videos?
Yeah, you can take screenshots. The driver doesn't support recording videos by itself, but the API in Chrome does, so it can be implemented. There is, for example, a web interface that comes with Chrome that you can use to control a headless Chrome, actually, from the browser, right? And it doesn't really stream image, it doesn't really stream video, but what it does is it continuously captures screenshots, sends them over the WebSocket. So it can easily be achieved. What kind of feedback does the developer get when the test fails in CI, and whether they need to reproduce it locally? So we use bhats. Now, in other cases, this works just with Mink, so you can run it with PHP unit or. So what you get is the assertion that failed. That's it. You don't get a screenshot, though you can configure it to make a screenshot and upload it somewhere. We don't really do, like the driver itself allows you to take a screenshot and save it when like the event triggered that a test failed, right? You can do that. But I don't think the screenshot itself is that useful, because if the assertion itself doesn't really tell you what broke, you're going to want to see for yourself the process running, because it's not necessarily the screen that you ended up with that caused the problem. It's more often that a step before, because there are a lot of steps, right? You go and you fill in some forms and you click some stuff, and then you end up with a bad result. It was most likely because that form wasn't filled, or the validation didn't pass, or something like that. So the final screen doesn't necessarily tell you what went wrong. But it's quite common for developers in my team, when the assertion itself doesn't tell them what happened, to run it locally, start a debugger, and see, because when it breaks in the debugger, it also stops controlling the browser, so you see the page at each point right slower than it would normally run. Yeah. Does that answer your question? Yeah. Anybody else? No? I'd like to thank you all. And since this is my first talk in front of an audience this size, I registered the event here and joined in. Now, obviously, you're not going to memorize the URL, but the slide's going to be up somewhere. And if you have any form of constructive feedback, I'd actually love to read it. Thank you.